So let's go ahead and let's do some basic naming of alkanes. Again, alkanes are just going to be carbon-carbon single bonds. That's the big difference between them. A few things about this one. You're going to have to number the chains and stuff like that. A lot of times when naming alkanes, it's better to do by example rather than write down 15 rules to follow. So a couple of things. I got to label each one of these carbons. You can draw either the condensed form, expanded, skeletal. I want to get familiar with skeletal because you probably see that the most in terms of organic chemistry. So a couple of things. You want to start numbering when you have the substituent on the lowest number. So for instance, I'm going to call this carbon number 1, 2, 3, 4. So I'm going to show you how to name it correctly, and then I'll show you how another alternative to numbering, which would be incorrect. So a couple of things with this. On carbon number 2, I have a chloro group. So it's a chlorine, but when it's an organic, we call it a chloro group. So on carbon number 2, I have a chloro group. So what happens is you want this substituent or functional group, any way you want to look at it, on the lowest number possible. If I start numbering from right to left, if I call this carbon number 1, carbon number 2, my chloro will be on carbon number 3, which you don't want. So you want that substituent to be on the lowest number possible. So always remember, you want that first substituent to be on the lowest number possible. So on carbon number 2, I have a chloro group. Now 1, 2, 3, 4. 4 means, now when I have 4 carbons in a row, I call that butane. That ANE means it's an alkane. That's what ANE means with that. So basically I got 2 chlorobutane. Should be all one word. So let's take a look at this. So this is a skeletal form. Now in this case right here, I'm going to call this carbon number 1, number 2, number 3, number 4, number 5. So 1, 2, 3, 4, 5. And the reason is now this group right here, which is a methyl group, that's the methyl substituent. So this is a methyl group. That's going to be on carbon number 2. So if I label it from left to right, which is kind of what we're familiar with because the way we write, I call this 1, 2, 3, 4. That would have been on carbon number 4, which you don't want. So we want this to be on the lowest number possible. There's 5 of these, so that's going to be pentane. The methyl group is on carbon number 2, so 2-methylpentane. Let's take a look. This one right here is a cyclic compound. So again, these are here were just like regular stick figures or straight organic compounds. This right here is a cyclic one, and there's 6 of them. So it's 1, 2, 3, 4, 5, 6. So instead of calling it hexane for 6 carbons in a row, we got to add a cyclo. So cyclohexane. This one right here. And again, whenever you have cyclic compounds, those are going to be the main groups. So this right here is going to be, and I'm going to call this carbon number 1 because that's where I see the substituent extended from. So I'm going to say 1, 2, 3, 4, 5. So it's cyclopentane. So don't forget, if it's 5 in a ring, or cyclic structure, when you look at it, we call it cyclo. And then a carbon number 1, so this is 1 carbon, that's 2 carbons. That's an ethyl group, so kind of recognize it. This is a methyl group, recognize it, and this is an ethyl group. Since there's only 1 substituent, I don't have to write the 1. I'm just going to call it ethyl cyclo pentane. Sometimes you may say 1 ethyl cyclopentane, but you don't have to write that 1. So normally it's going to be dropped.